Hi, this is Jeline from the Honors Tutorial. Welcome back to part 2 of our topic, which is about multiplication of radicals under Math 9. So, this is the continuation of our examples. We have here square root of 15 times square root of 3x. And this is how we are going to solve for it. Let's write solution. Since we have here same index, we can just simply multiply 15 times 3x. So 15 times 3, that is 45. Please copy the radical symbol. So it's 45x. Just copy x. And then you have to think of factors of 45. The first factor is a perfect square number, while the other factor is not. So we can have 9 times 5 because 9 is a perfect square number and 5 is not, times x. The square root of 9 is 3, so we will write it here outside. Square root of 5 not possible, and x not possible also. So they will still remain inside the radical symbol. So 5 times x, so that is 5x. So the answer for example number 5 is 3 square root of 5x. Next, we have here example number 6. Let us simplify first square root of 8 because it is possible to simplify it. Let's write our solution here. So we have here 4 square root of factors of 8. The first factor should be a perfect square number while the second one is not. So for 8, we can use 4 times 2 times 2 square root of 3. Then let's continue. Let's copy 4, which is outside the radical symbol. Square root of 4, that is 2, so it will become times 2 square root of 2 times 2 square root of 3. So let's simplify 4 times 2, that's 8. And then just copy square root of 2 times 2 square root of 3. So in this part, we can just simply multiply 8 times 2, that is 16. And then for the numbers inside the radical symbol, you can just multiply them 2 times 3. So we have here 16 square root of 6. And this is the final answer for example number 6. Now let us have another example. So this is example number 7. But I want you to notice that we have here different indices. So therefore, we have to change that into equivalent or same indices. So we have here solution. We are going to transform it into exponential form. So then it will become 5 raised to 1/3 times 7 raised to 1/2. And then I will focus first on the fractions that we have here. So we have here 1/3 and 1/2. I will write it vertically and then you have to look for the LCD of 3 and 2. How? Let me write it here. I will use the ladder method. So 3 and 2. Think of a prime number that can divide 3 and 2, and that's 3. 3 divided by 2 is 1. 2 divided by 3, not possible. So bring down 2. And then think again of a prime number that can divide 2. That's 2. So bring down 1 since it is already 1. 2 divided by 2 is 1. And then what you are going to do is to multiply the prime numbers that you get. So you have here 3 times 2, that is equal to 6. So therefore, your new denominator is 6. For us to get the numerator, we will be dividing them. 6 divided by 3, that's 2, times 1, that's 2. And then 6 divided by 2, that's 3, times 1, that's 3 still. So now, our equation will be 5 raised to 2 over 6 times 7 raised to 3 over 6. And then we can just simply change that into radical. So now it will become the sixth root of 5 squared times the sixth root of 7 cubed. Now we can just simply multiply them. So copy the sixth root since they have the same index now. And then simplify. 5 squared, that's 25, times 7 cubed, that is 343. And then we will multiply 25 times 343. So we have here the sixth root of 25 times 343. And that is 8,575. And this is the answer for example 7. Let us have another. We have here the cube root of 2 times the fourth root of 9. Same process. Let's change the indices into similar ones because we have here different indices here. So therefore, they are unlike radicals. We have to change them into like radicals. So this will be our solution. Let's transform this into exponential form. So it will become 2 raised to 1 over 3 times 9 raised to 1 over 4. And then let's focus on the fractions first. So we have here 1/3 and 1/4. Let's write it vertically and then use the ladder method. So we have here 3 and 4. We are just using the denominators and then think of a prime number that can divide 3 or 4 or 3 and 4. So it is 3. So 3 divided by 3, that's 1. And then bring down 4. Think of a prime number again that can divide 4, and that's 2. So we have here, bring down 1 again. 4 divided by 2 is 2. And then think of a prime number again that can divide 2, and that's 2. So we have here 1. 2 divided by 2 is 1. So the prime factors that we have here is 3 times 2 times 2. So 3 times 2, that's 6, times 2, that's 12. So 12 is our new denominator here. So it is equal to 12 and then 12 here. So 12 divided by 3, that's 4, times 1, it's still 4. 12 divided by 4, it's 3, times 1, it's 3. So now our new equation is 2 raised to 4 over 12, this one, times 9 raised to 3 over 12. Now we can change this now into radicals. So it will become the 12th root of 2 raised to 4 times the 12th root of 9 raised to 3. And then we will simplify. So 2 raised to 4. So what is 2 raised to 4? So that is 16. So we have here 12 and then this is 16. And then we have here 9 raised to 3. So 9 raised to 3, that is equal to 729. And then let's multiply it. So 12 root of 16 times 729 is equal to 11,664. And then let's get the square root of 11,664 just to simplify it. And that is 108. So we have here the 12th root of 108 raised to 2. Because 108 raised to 2 is 11,664. Since we have here 2 and 12, we can divide it. So we can simplify it and divide it by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. So we have here 6. And then inside we have here 108 raised to 1 or 108. So the final answer is 6th root of 108. And this is for the second part of our discussion. Please watch the third part of this because there are more complex examples for the third part of this topic, and that is also the last part of our topic. So please watch it. And if you have further inquiries about us, kindly message the Honors Tutorials page. Thank you and God bless.